I'm going to pick up where we left off last class about factoring completely. We didn't get to 3 examples, so these are the last 3 examples that we'll go over. The first one is factoring by grouping, which we've already covered. Basically, if it has 4 terms, you need to put them in some sort of order where you can group 2 of them together and find the greatest common factor. So I'm just going to start by taking z squared plus 5z squared, and I'm going to look for their greatest common factor. They both have a z squared, so I'm going to factor out a z squared from the first 2 terms. Now when I factor out a z squared, what I'm left with is 1z plus, if I have 5z squareds and I take away a z squared, I just have 5. Now the second 2 terms, we do the exact same process with carrying down the sign in between the 2. So since it's a subtraction sign, I'm going to put a subtraction sign. 4 and 20 are both divisible by a 4, so I'm going to divide by a 4. So negative 4z's divided by negative 4 is positive 1z. Negative 20 divided by negative 4 is positive 5. Now all we have left to do is regroup. First, I ask myself, what do they have in common? Well, they have a z plus 5 in common. So I write that first. Then I ask myself, what don't they have in common? Well, they have a z squared and a minus 4. So that becomes my second set of parentheses. Now, normally I'd be done, but I noticed that I still have a z squared. So I need to look at that piece. Z squared minus 4 is actually the difference of perfect squares. So what I'm going to do is I'm going to factor it. So factors of z squared are z and z. Factors of negative 4 that are multiplied together to give me 4 is 2 and 2. But since I want one positive and one negative because I want what's called the conjugate, I want those middle 2 terms to fall out if I factor. Now we have to be careful when we're doing this, because we cannot forget that term that we factored out that they did originally have in common, which is z plus 5. So there is my answer. Z plus 5 times z plus 2 times z minus 2. And you can put those in any order because it is commutative. Let's try another example. These examples are going to use a couple of our other properties that we're used to using. The first one I see is 16x to the 4th minus 81. Now we haven't really factored anything that has an x to the 4th in it, but we have factored x squareds. So my first thought in doing this problem is to go ahead and do what we call U-Substitution. Basically what U-Substitution is I let u represent some value in the math problem and I replace it with that value. So I'm going to say u is going to be x squared. Now if I do that, what I'm left with is 16. If I have x to the 4th, well, how many u's would I need? I need to multiply by 2 of them to get x to the 4th, so we put u squared minus 81. Now if you notice, those numbers that we have, 16 and 81, are perfect squares, and there is a subtraction sign in between the 2. So I can do difference of perfect squares. What square gives me 16? Well, that is 4, so this is going to be 4u. What square gives me 81? Well, that's 9. So on the last one, I didn't list this way, but maybe it's helpful this time to look at it this way. When we write our parentheses, the formula says a plus b times a minus b. Okay, so if I do that, it'd be 4u plus 9 and 4u minus 9. Now if you look at the problem, I don't have any squareds, but I'm not done with the problem yet because I need to take that x squared and put it back in where I see u. So when I do that, I get 4x squared plus 9 and 4x squared minus 9. Oh wait, we've opened a whole new can of worms. I've got x squareds in there. But I can only factor x squareds if it is a minus sign, and I do see that. So we don't do anything to the 4x squared plus 9. But just like the last problem, like we did up above, we're going to have to factor the 4x squared minus 9. Well, 4x squared minus 9. Let me think about this. 4x squared is equal to 2x to the second. 2x times 2x gives me 4x squared. 9 is the same thing as 3 squared. Well, then that will break down. So we do 2x plus 3 and 2x minus 3. I don't have any squareds left in that problem, so that's great. But I do have that x squared plus 9. I can't do anything to it because it is an addition problem instead of a subtraction problem. So that problem is done. I'm going to move this up here so we can kind of get it out of the way and so we can look at the second example. The second example on this page that we're going to do, and this is actually the last example, is kind of still that same idea of U-substitution. First, before we start, we look at our flow chart and we see what they all have in common. Well, 3, 15, and 18 are all divisible by 3. And they all have at least a p squared. So I'm going to take a 3p squared out. So 3p squared. Well, that leaves me with 3 divided by 3 is 1. 8 p's taking away 4 p's, 2 p's, excuse me, is 6 p's. Plus 15 divided by 3 is 5. 5 p's take away 2 p's is 3 p's. Plus 18 divided by 3 is 6. If I have 2 p's and I take away 2 p's, I don't have any. Well, I'm good there. But now I notice I have p to the 6th and p to the 3rd and a constant. Well, that looks a lot like an x squared plus x plus constant problem. But the 6 and the 3. Well, 6 is double 3, so maybe I can use U-substitution again. This time I'm going to let u represent p cubed. Now when I do that, what I'm left with is p squared, because 2 times 3 is 6, plus 5p plus 6. I do not forget my 3p squared that I originally pulled out. Wait, I have a problem. That's not supposed to be a p, that's supposed to be a u. So I need to change that. So I can have something that has 2 different variables in it. Now I factor what's left over, factors of 6 that give me 1. Wait, was it 1? No, it wasn't 1. It was 5p cubed, so it's 5u. Factors of 6 that give me 5 are 3 and 2. I don't use 6 and 1 because both signs are addition. So it's u plus 3 and u plus 2. I bring down my 3p squared. I write my problem back in, so 3p squared. U was originally p cubed, so p cubed plus 3. And now I have p cubed plus 2. Now I have to ask myself, am I done? Well, I have p cubes, but last time I checked, 3 and 2 are not perfect cubes. So I am done. So the answer to my math problem is 3p squared times p cubed plus 3 times p cubed plus 2. Hopefully this is helpful, and I'm sorry that I made a few mistakes along the way, but we're all human, and have a great day.